A little known fact about myself, I used to love running cross country. I used to do that in high school. And each race we ran was 3 miles. So you can see here, for one race it would be 3 miles, 2 races it would be 6 miles. You get the idea. 3 races, 9 miles. Um, so I'm trying to do a little expression here. We want to fill in this space right here with an expression or a rule. Whenever you see a chart going down like this, you can see all the races, they go down this way. That means the rule is going to be found by going across and comparing the two things here. We have races in miles. So I'm trying to compare races in miles. So yes, this is going up by 1, and this is going up by 3 each time. But that's not what I'm trying to get at. I'm trying to compare how these things change, how races and miles change. So how do we get from 1 to 3? Well, we could add 2. If we add 2 though, 2 plus 2 doesn't equal 6. And I'm just going to clear this out of your way. And 3 plus 2 doesn't equal 5, does it? So that wouldn't be what we're looking for. How else can we get from 1 to 3? Well, to increase numbers, we can always multiply, right? So I'm going to multiply this by 3. And that will work for the next one too. 2 times 3 is 6. And then the last one, 3 times 3 would be 9. So my variable here is r. So I'm just going to write r times 3. And that's an expression, right? It has a variable, r, has an operation sign, it has a constant, the number 3. That's never going to change. This is the same problem. It's just that the chart's going across. So I just wanted to show you the chart goes across and the rule is going down. So again, I'm comparing races to miles. Those are the two things that I'm trying to compare here. So 1 to 3. Well, we multiply by 3. 2 to 6, we multiply by 3. And I'm going to put the same thing in this box right here. It's real important that you don't put 12 in here because this is r. It isn't 4. If it said 4, I'd put 12 in here. But r really stands for any number. So it could be 4. It also could be 5. It could be 10. It could be 20. It could be 100. Who knows what the r stands for? Let's look at another example here. So this is number of pentagons. A pentagon is a 5-sided shape, in case you didn't know. So if I have 1 going into 5, well, that would be plus 4 or times 5. Let's see, 2 plus 4, that doesn't equal 10, but 2 times 5 does. 5 times 5 equals 25. And notice I highlighted this blue because it's a little bit different, right? We don't have a little pattern going down. The only pattern we have here is going across, and that's times 5 each time. Okay, so that's why in that last one I showed you, yeah, sometimes you'll have a pattern here, but that really doesn't matter. What matters is the relationship between the two things which we're comparing, which in this case is the number of pentagons and the total number of sides, excuse me. And so I'm going to put p, and what's the rule here? Times 5. And again, we have an expression because we have a variable, an operation, and a constant. That one right there was p times 5. But this one right here is, I'm going to move my pentagon. So you can see here, the total number of sides is 5. And the number of pentagons. It's very similar to the last problem, but it's not exactly the same. So if I go up here, I'm just going to get my pen again. What's happening right here? We want to figure out the rule right here. Well, to get from 5 to 1, how do we do that? We divided by 5 this time. Rather than multiply, we divide by 5. So the variable is actually sides, whereas before, you see over here, the variable was the number of pentagons. So we just switched the variable, and we're doing the reverse here. Divided by 5. Divided by 5 is going to hold up for s too. So it's just going to be s divided by 5. And that looks like a 5 a little bit, but that's my s. Hopefully that helps you with using charts and expressions.